Introducing the Muse Hub. Using electrodes to measure brainwaves, we can monitor and hopefully increase productivity in the workplace or home. This increase comes from tracking brain activity and limiting interactions while working. Sometimes it's hard to stay focused at work. When that interruption comes in the middle of inspiration, it can be very difficult to get back on track. The Muse Hub can inform your workers on the best time to approach you and when to leave you uninterrupted. Tracking your brain activity over time can also help you set your schedule to maximize productivity. Before developing our system, we looked at two competing products. The NeuroSky is a research-oriented headset that can track brain activity, but lacks a form factor that would make it acceptable in the workplace. The iFocus band tracks brain activity and recommends breathing exercise when you are stressed, but doesn't accomplish our stated goal of limiting untimely distractions. Our final design. In place of using a complicated series of shift registers to control all 37 full-color LEDs, we used NeoPixels. These lights are hidden in the band of the hat. We light them in different patterns to show different types and levels of brain activity. These patterns were chosen to try to signify the frequency rate of the brain wave. We tried to map higher frequencies with patterns that seemed faster and lower frequencies with patterns that took a while to reach their full brightness. Delta, from 1 to 3 Hz, is most present during deep, dreamless sleep. Theta, from 4 to 8 Hz, is evidence of deep relaxation and meditation. Alpha, from 9 to 13 Hz, is most prevalent when you are relaxed and calm. Beta is most prevalent when inspiration strikes and is seen in the 14 to 30 Hz range. The design of the system can be relatively simple. The potentiometer controls simulated wave frequencies and activates the different display modes. Output to the NeoPixel strip is handled by Arduino code and modified functions from the NeoPixel Arduino library. Because NeoPixels only require a control voltage in, and a ground, the wiring scheme can be very minimal. A simple sine wave is also generated to simulate reading the input from the EEGs. In the future, we would like to incorporate the Texas Instruments EEG front-end chip we received into our product to measure the incoming signals from the electrodes built into the hat. OpenBCI makes a processing sketch that would handle the interpretation and enable the second half of our goal, allowing the user to track their brain activity over time and to identify the most productive times of the day. This project was conducted at the Georgia Institute of Technology.